Assalamualaikum warahmatullahi wabarakatuh. We are from Group 7 to present the application of first order differential equation. This is our group member Nadira, Atika, Amira, Sofia and Najla. Let's move to our question.
Question given, a tank initially holds 10 gallons of fresh water. At t equals to 0, a brine solution containing 0.5 pump of salt per gallon is poured into the tank at a rate of 2 gallons per minute. Based on the diagram, now we can find the solution by using linear equation method. Knowing that ds over dt is equal to rate in minus rate out. Now we can substitute ds over dt is equal to 1 minus s over 5. Next, we have to find the integrating factor and substitute it into the equation, which is mu t times s equals to mu t times with qt. And lastly, we can get the solution, which is equal s equals to 5 plus c e to the power of negative 1 over 5t. Next, to determine the amount of salt, we have to set c equal to 0 and s equal to 0. And after that, we substitute into this equation. So we can get c equals to negative 5. So the final answer is SE equals to 5 minus 5e to the power of negative 1 over 5t.
So we'll move to the next question, asking about concentration of salt. To find concentration of salt, we use the basic knowledge of chemistry, which is concentration equal to the amount of salt over total volume. Since we already found the equation for amount of salt in the previous question, and the total volume is also given in the question, we can substitute the value into this equation. So the concentration is equal to 1 minus e to the power of negative t over 5 over 2.
For question C, the model assumes no air resistance and constant gravitational acceleration, which simplifies the motion to an ideal case. Discuss how realistic these assumptions are in real-world conditions, which is the assumption should be no air resistance, which is we only consider the force is gravity, and secondly, constant gravitational acceleration, which is g does not change with height. Okay, for the point which is imperfect mixing, salts might not instantly distribute uniformly. Secondly, variable rate in or rate out. Flow rates may temporarily increase or decrease depends on the situation. And secondly, external disturbance, which is due to temperature changes, which is the temperature also contribute to the external distribution, which is also contribute to the results.
How could engineers improve the model to make it more realistic? First, improve the mixing representation. So engineers can use multiple tank, which is CSTR in series models. Instead of assuming perfect mixing, engineers can model the tank as several smaller, partially mixed zones connected in series. This better represents how fluid actually flows and mixes inside a real tank. Second one, we can include additional physical or chemical processes. So first, density variation. Account for how salt concentration affects density, which changes mixing patterns. And the second one is precipitation or reaction. If salt can crystallize or react, include a removal term in the model. And the third one is make inflow and outflow variable in time. Replace constant rate with Q in T and Q out T to reflect pump fluctuations or control adjustment. This captures realistic operational changes, leaks, and or equipment behavior.